Hi there, BC here from bcr.com, and here we go with part 2 of the 1-point tutorial. Today we're gonna learn how we can take precise dimensions and put them into 1-point perspective so that the result is exactly what you would see in those conditions in a real life environment. So, at the end of the lesson, you'll be able to take any measurable object and draw it from any angle at any desired eye level and from any established distance from it. First of all, if you didn't watch my first video, please pause right now and go watch it, because you need to know those things to be able to understand this tutorial. It's really important that you do that, as well as, giving me a thumbs up if you like this video, subscribing to my channel and hitting the bell button, because I will put up new video tutorials every week and you don't want to miss on that. I will put in the description a link to the first video for you guys. So, what do we need to know in order to calculate our 1-point perspective? Let's take, for example, just an empty room. This is the easiest example possible that we can work with. We need to obviously know the dimensions of the room, meaning the depth, the height, and the width. Second, we need to know where exactly we're standing when looking at this drawing, because of course that the image changes as we move from one point to another inside the room. Okay? Our position in space is characterized by 3 dimensions: our distance from the back of the room, our distance relative to the side walls, and the height at which our eye level sits relative to the drawn environment. This all may sound very easy right now, but please pay attention, because it's gonna get pretty complicated by the end of the tutorial, and I don't want you to get lost along the way, so just please be careful right now. Okay, let's do a quick overview of what the steps are going to be. First, we're going to draw the front view of the back of the room, okay? Which is just going to be a rectangle representing this back wall, okay? Then, underneath that, we're going to draw our ground floor. I'm using colors so that it's very obvious what's going on. So we have our front view and our horizontal view. From this image, we're going to use our horizon line, which is going to be at a height relative to the height of the room. Okay, so if this room was 20 meters high and our eye level was 2 meters high, it would be at a 1/10 of the height, of the maximum height. And if this room is like 3 meters high, which it is going to be, it's going to be like 2/3 of the height. Okay, then we're going to use the vanishing point, of course, and we're going to use the station point. The vanishing point is the point in which we're looking straight at the wall, and the station point is the point in space where we are positioned. Okay, now let's see the dimensions. We're gonna use a 6-meter deep room by 4 meters wide, and it's going to be 3 meters high. Okay, we're going to be standing at 7 meters distance from the back of the room and 3 meters distance from the right wall of the room. Okay, and our eye level will be at 2 meters. I'm just gonna leave this image right here for the rest of the demonstration so that we can always refer back to it. Step 1. We're going to draw our ground floor line level. This will separate our 2 main views that we're going to use. The front view, which is going to be above the ground floor line level, and the horizontal view, which is going to be underneath it. Next, let's draw our front view. In this case, I'll draw a rectangle which is 4 by 3 meters, and I'm going to call it ABCD. Next, step 2. We will draw our eye level, which will be relative always to the height of the drawn environment. In this case, it will be at 2/3 from the ground up, since we're 2 meters high and the ceiling is at 3. As we learned in the previous lesson, this is a horizontal line parallel to the ground plane line. Step 3. We determine the vanishing point using the information we have about our distance relative to the side walls. we are 3 meters away from the right side wall, so we will draw a vertical line right there, and where this line intersects the horizon line, we will have our vanishing point. This is the exact point where our eyes are directed. Imagine if you shot lasers from between your eyes. This is where your target would be. Step 4. We draw our horizontal view of the room. We will align this with our front view and use the depth of the room to draw a 4 by 6 meter rectangle. The line coming down from the vanishing point is our line of sight. Let's name these points E and F. Let's take a second and see how this happened. So we have our 3D view of the perspective, and we can see the line of sight projected on the ground plane as well as the room's horizontal view. What we did was take these two views and make them level with one another, meaning that we rotated the ground floor so that it's vertical and right underneath the front view. Step 5. We need to position ourselves in the horizontal view. We said in the beginning that we are 7 meters away from the back wall. We'll measure 7 meters here and mark this point, and then we're gonna name this point S from station point. This point and the vanishing point are going to be the main keys that we're gonna use in our construction. Step 6. Now we're ready to go in perspective. So from the vanishing point, we'll bring two lines towards us by drawing a line through point C and D. This is where I want you to really pay attention, because this is crucial. These lines in perspective are these lines from the horizontal view. Literally. We will use this horizontal view to measure these lines, but I want you to really see these ones as the same ones from the horizontal view, just now seen in 3D perspective. Okay, they're literally the same ones. Step 7. Let's now put the station point to work. We previously said that we can use the horizontal view lines in order to measure these lines in perspective. This is where the station point comes in. It's really easy, but just pay attention. Any point from this line can be brought up in perspective and perfectly accurate measured if we bring a line from SP through that point and up to the perspective line, meaning its correspondent perspective line. Got that? Let's do that for 2 points, closing the perspective. We'll draw a line from SP, go through our lower right corner and intersect this line with its correspondent perspective line. This is where point F is now FP, meaning F in perspective view. Same thing for point E. We draw a line from point SP, go through E and find EP, which is where E is in perspective. We now have our ground floor plan in perspective. We notice that C and D remain in the same point, so C equals CP and D equals DP. Let's see exactly how this happened. Every graphically vertical line from the horizontal view is in 1 point perspective, a line coming from the vanishing point, because it's a line going straight forward away from us. These two sidelines are not magical, meaning that what we've just done with those measurements, we can do with any random line in 1 point perspective. Let's draw 2 more vertical lines in the horizontal view, just completely random, and name them 1 and 2. We'll make the second one not touch the ground floor line. How do we translate these 2 lines in perspective? The same way it happened with the sidelines. We'll bring line number 1 in perspective by drawing a line from the vanishing point through the point where it intersects the ground floor line. Now, how do we measure that in perspective? Very simple. We just take the measurements from the horizontal view and bring them into perspective using our station point. But what about the second line? It's not connected to the ground floor line, so we can't just bring it into perspective yet. We need an auxiliary construction line, so we'll gently extend it to the ground floor line, and from that point we'll bring our second line in perspective. Now, to measure its distance, it's very easy. We just need to draw 2 lines from SP through the first and second point, delimiting the segment, and we have it in perspective. Step 8. Let's see how to measure heights in perspective. So I guess you noticed by now that in order to measure distances in perspective, we need our distance in front or horizontal view, and we use VP or SP to bring it forward. This is really the key principle to all this method, because we start with lines that are precisely measured and we keep bringing them forward in perspective. So now, to bring these two vertical lines from our front view in perspective, we have to use the vanishing point and bring lines from the vanishing point through points A and B. Now we can draw an infinite amount of equal lines between these two lines coming from the vanishing point, but if you want to see where the room ends, we need to draw a vertical line from points FP and EP. You will notice that AP and BP are on a perfectly straight horizontal line, and they should be if your calculations are correct, as are mine because I use the CAD software for this. So what you need to know is that this method works perfectly every time. Just you need to be patient and you need to practice, because if you worked in a CAD software like I did, this would turn out absolutely perfect, but you're not. You're working most likely on paper, so expect some errors from yourself, especially in the beginning and later on. This takes a lot of time to master, so just be patient with yourself. Next, we're going to learn how to measure along the width of the volume, okay? Meaning along the width of the room. How do we take a measure from EF to EPFP? Okay, and then we're gonna go to volume. So if you didn't understand the steps so far, please go back and listen again and watch the video again, because it's gonna be obviously a little trickier with the volumes, and you really need to know how to calculate lines before we move to volumes. Let's see now how to measure distances along the width of the ground plane. So to do that, we can either use SP and go through EF to measure on EPFP, or use V and go through CD to measure on CPDP. Use the first line, which is EF, and then we'll go backwards through CD and check if the method is valid. Let's measure 1 meter from the right. We'll measure first on EF, and now to bring it in perspective, we'll drag a line from S, and where that line intersects EPFP, that's where 1 meter is in perspective. Now, using the same method but going backwards, if we take this point and go towards VP, we should hit line CD at exactly 1 meter, since we could have used that measurement just as well. So we draw this line, go towards VP, and see where it intersects line CD. And we see that it hits exactly at the same distance as on line EF, since they are on the same vertical line. Let's measure 4 more distances, one from EF, one from CD, and one from AB, measuring on APBP. Let's place all of them randomly except for this one on AB, which will be on 1 meter from the right. We want to see if this meter will come right above the one below. They should, right? We'll first measure what we just learned. So to bring this point from EF in perspective, we just need to draw a line from SP. We'll bring it up to EPFP, and this is where that distance hits. Now let's draw this one from CD. We'll drag this distance from V, and it hits right over here. Okay, so we placed our distances into perspective. Pretty easy. Now the same thing with our random point from AB. We'll drag it to APBP, and this distance will be equal to this one. Now the moment of truth. If we bring this 1 meter forward from AB to APBP, is this going to be in line, perfectly aligned vertically with the one on EPFP? Let's see. We'll drag this line right here, and it hits APBP there, in that point. Okay. Now, we can see that these measurements are perfectly accurate, because no matter how we measure, in which order, we get the exact same result. Let's now place two boxes in this perspective. I already drew them in a horizontal view. The first one is on the top left corner, having 0.5 by 2 meter dimensions and a height of 0.5 meters, and the second one is 1.5 meters and by 2, and we'll put it here at 0.5 meters from the right wall and 2 meters from the back wall. How do we draw this in perspective? We need to bring their lines in perspective first, so the lines going to the vanishing point first, then measuring their depth. To do that, we just bring these lines from the VP. This left one is already in perspective because it coincides with the left wall line, and to measure their depth we just need to drag lines from the SP going through their distance in horizontal view and up to their equivalent perspective view. So this is the base of the box in perspective. Now let's calculate the height. We'll just draw vertical lines from each of the 4 points, and to bring the right dimension in perspective, we first need to measure it in front view. Then we'll bring a line from the vanishing point, and here it is. Now I'll just go around the form up here to find the rest of the corners, and that's it, the first box. To draw the second one, we first need to extend these lines towards the ground floor line in order to bring them in perspective. Then we'll measure the distance just like we did with the first one, and here we have our base for the second box. Next we need to measure the heights, so from each of the 4 corners from the base we're going to draw a vertical line, and then we're going to measure the real height back in the front view, and then bring it forward from the vanishing point and go around the form to complete the shape. Lastly, we'll do a box that is rotated in space, so it is a rectangular box but it's rotated away from us. How do we measure that? There are more ways to do it, but let's use what we've just learned. To find the base of the object, we need to find all the vertical lines that these points sit on. So we'll draw perpendicular lines from each of the 4 points to the ground floor line. Next, we'll bring them in perspective by drawing lines from the vanishing point through each of the 4 points where the perpendiculars hit. Next, to find the exact position of the points in perspective, we need to use SP. So let's draw lines from SP through each of the 4 points in the horizontal view, and where they intersect the perspective lines, we found our 4 points of the base in perspective. Next, we need heights for each one. So from each of the 4 points on the ground floor line, we'll draw vertical lines with the real height of the object, which will be random for this example because it's irrelevant, it looks the same regardless. Next, bring these heights in perspective, just like with the 2 other boxes. We draw verticals from the base points in perspective and then intersect them with the lines coming from the vanishing point. And that's it. Now we draw the complete volume, and here it is. Just a bonus tip, since this box is rotated away from us, we said in the first lesson that it's in 2-point perspective. Let's check that out. If I extend the lines up to the horizon line, we'll see something pretty amazing. All the lines going towards the left converge in the same point on our horizon line. The same thing with the lines going towards the right. They all converge in the same point, again also on a horizon line. This is what 2-point perspective means, okay? So all the lines going towards the left, which are parallel to one another, are going into the same point. Alright, and that is it. I have bored you enough with this lesson. I hope you learned something today. I hope this really helps you, because it sure helps me. I have more of a technical thinking. My background is in architecture. I graduated from an architecture school. So this kind of mathematical, let's call it mathematical, but it's not really, it's descriptive geometry, really helps me understand why perspective works the way it does, and I hope it helps you too. I hope you liked this lesson, and if you did, give me a thumbs up, subscribe to my channel, and leave me a comment. Tell me, why are you torturing yourself with this kind of perspective? I'm curious. Okay, and of course, if you would like me to teach something specific about perspective, if you have any questions, please leave them in a comment below and I will go through them. Okay, thank you. Thank you for sticking with me for so long, This has been a long ass tutorial. I hope you liked it, and I will talk to you next time. Bye bye.